Hello, hello. It is good to be here, and I hope anyone who's watching this is doing well. Uh, Today I'm simply just going to be learning some code, nothing much. Might play some Hollow Knight later, but yeah. Hope you guys are doing well. I've already started on this website a while ago, boot.dev. So and I think I'm not. Yeah, I don't know. Put it there now. My phone. I'm gonna my phone check how how my voice is. So don't mind that. But okay, so don't slow that. Oh, well, my voice seems to be doing well. Got into that. Okay, so variables are how people store data, program runs, printing data by save that variable, use it, and change it before printing. Any variable. The name that we give to a value, for example, make a new variable, my height set to 100, yeah, okay, or we can define a variable called my name and set it to the text string lane. Alright. Assignment. You can try right here as well. So on the first line of code, create a new variable named player house, set it equal to 1,000, okay? Okay, so once I have a variable, we can access its value by using its name. For examples, this will print 100. Print my height 100. Okay. So the first one, where for health, simply just, oh wait, no, equal 1,000. Should be it. Yeah, okay. Should be it. There we go. Alright, let's listen one done. Okay. So we're just by 100 here, and I'll lay down. Okay. So variables vary. Variables are called variables because they can hold any value, and that value can change. It varies, obviously. For example, this code prints 20. Like between 20, we find value of acceleration. 20 and overwrites whatever was being held in the acceleration variable of 4, which is 10. Okay. Okay, assignment. We reduce our kills as they take damage for each print function. 100 less than 1 before. So what I went like this. So what if I do player health equals 900, player health 800, no, not that, 800, player health equals 700, player health equals 600. You correct? Yeah. Alright, that works. Nice. 3 achievements and a chest. 2 achievements and a chest. Alright. Storing results. Now we know how to store and change the value of variables. Let's do some math. Here are some examples of mathematical operations in Python syntax. Okay, some addition, okay, so addition, subtraction, multiplication, addition. So AB, it would be A minus B, yeah, A times B, and A divided by B. Okay. Parentheses can be used to order math operations. Okay. So, a new variable called armor house on line 4, and set it equal to player health times armor multiplier. Yeah, so, armored health equal player health times armor multiplier. Okay. Do I have to, like, act? Oh, 2000. Yeah. Uh-huh. Alright. That's neat. Okay. We don't touch anything below this. Okay. Negative numbers in Python will display public spec, add a minus sign. Okay. Assignment, when our hero walks through the poison, their health should go down when the hero is gaining 10 health. Okay. Nice. That's about that. Yeah. Alright. Comments don't do anything. They're ignored by some interpreter that said they're good for what the name implies. Adding comments to your code in plain English or whatever language you speak. Single line comment. A single hashtag makes the rest of the line a comment. Okay, so like how I saw earlier with the hashtag. Yeah. Okay. Multi-line comments, aka doc strings. You can use triple quotes to start and end multi-line comments as well. Current font does doing that, and then adding the code found below will print hello world to the console. And useful if you don't want to add the hashtag found to the start of each line when writing paragraph of comment. Assignment. Line number 1 in the code would meant to be comment without forgetting to use the correct syntax. Okay, that's okay. So that should be what it is. Run. Alright, that's easy. That is easy enough to understand. Um, variable names. Variable names cannot have spaces. Spaces are continuous strings. Characters. And the creator of the Python language itself, Guido van Rossum, I'm assuming that's how you say it, employs to use snake underscore case for variable names. What is snake case? It's a style for writing variable means. Here are some examples of different casing styles. Snake case. All words are lowercase and separated by underscores. So this here helps one. Yeah. Languages like Embedded, Python, Ruby, or Rust. Okay. Camel case. Capitalize the first letter of each word except the first one. So like heroes. Okay. I'm gonna finish reading this, so kind of feel important. I like, yeah, the recommended is JavaScript, Java, both of the Java ones. Pascal case. Capitalize the first letter of each word, like the third hero house. C pound and C++. No casing, all lowercase with no separations, which is not up here. Okay. Clear your Python code will still work with Camel or Pascal. Can we please just have nice things? We just want some consistency in our craft. Oh, if you want to use a snake case for you, do it for me. I beg you. It's just funny. Okay. A variable name. Variable names cannot have bases. They're continuous strings of characters. The valid case. Okay, so pretty much just read this from that hero house. Okay. Basic variable type. Python has several basic data types. Strings. Oh. Okay, I'm gonna keep that there. In programming, snippets of text are called strings. The list of characters joined together. We create strings by wrapping the text in single quotes or double quotes. That said, double quotes are preferred. Nameless single quotes, boot.dev, not so good. Okay, yeah. Okay. Numbers are not surrounded by quotes when they're declared. A integer or int is a number without a decimal part, like positive integer, negative integer. Okay. A float is a number with a decimal part. Pretty simple. It's understandable. Boolean. A boolean, or bool for short, or boolean. I'm saying boolean. A boolean or bool is a type that can only have one or two values, true or false. As you may have heard, computers really only use ones and zeros. These ones and zeros are just true, false, booleans values. Boolean, I don't know. Boolean values. Same bool from now on. Is underscore tall, true, is underscore short, false, yeah. Okay. So, assignment. Fix the bugs in the code. Player health should be an integer, and player has magic should be a boolean. Okay. I'm gonna fix where my PNG, my little image is. There we go. Okay. I just want to cover the text on the bottom left. So this should just be like that. And then player has magic should be a boolean. So it should be like that. Yeah. Alright. Hey, Pokemon. America's F strings in Python. I ever played Pokemon and chosen a funny name so that the in-game messages would come out funny. So the America's strengths made it follow mood boards around. So all that kind of funny. In Python, we can create strings that contain dynamic values with the F string syntax. Num underscore bananas equals 10. F underscore string F. You have num banana. Number of bananas. It's like, so 10 bananas. Print F string. Okay. Opening quotes must be preceded by an F. Variables within curly brackets have their values injected into the string. It's just a string with a special syntax. Okay. Function matters. Okay. Assignment. Fix the bug on line 7. Use an F string to inject the dynamic values into the string. Replace name with the value of the name variable. Okay, so print. Okay, replace race with the value of the race variable. Replace age with. Okay, so simply just like make them lowercase, I'm assuming. Do not hardcode the values into the string. For example, this is not the solution we're looking for, even though it happens to work in this case. Okay, so name, race, age. Is this what they want? No. Oh. Oh, I was supposed to say don't. Wait, don't above. Oh no, this is the one. Name. No, okay. What the? Oh, wait, hold on. Let's see. What if I move that? Does that? No. Okay. I'm gonna fix fix this. Okay. Hey. Hmm. Do I have to? What? Okay. So assignment. F. Okay. Um. Hmm. What if I do F underscore bring me remove that and F underscore bring F name a right. I don't feel like this will work, but it wouldn't hurt to at least try it. So that does work, but not correct. A few characters off. Hmm. Oh. There we go. Alright. That is cool. That's nice to know. Alright. I'm gonna get back to this. Okay. Non-type variables. Not all variables have a value. It can be an empty variable by setting it to none. None is a special value in Python that represents the absence of a value. It is not the same as 0, false, or an empty string. My mental acuity equal none. My value of my mental acuity in this case is none. until we use the assignment operator equals to give it a value. Okay. None is not a string. None type is not the same as a string with a value of none. My underscore none equals none. This is a none type. My none equals none. This is a string with the value of none. Okay. Declare a variable named enemy instead of none. Don't change the print function. Okay, so oh, I'm gonna do that. I'm assuming it is simply enemy equals none. It's simply that. Yes, okay. Submit. There we go. Alright. On to number 11. And there is a video.
The none type in Python is weird, and discovering it in Python is probably really mind-bending in the same way that discovering the concept of zero would have been mind-bending to the ancient Sumerians. Let's start with an example. I'll create this variable age selection and set it equal to none, and that's none with a capital N. It's important to note this is not the same thing as the string none, which would be surrounded in double quotes. None is its own special keyword in Python. It's not just another string. For example, hello world is a string, 1 is an integer, false is a boolean, and none is actually of the type
Boolean.
none type, which is its own special categorization. Strings and integers both have infinite possibilities of what they could be. There's an infinite number of strings that you could store in a string type or integers that you could store in an integer type. A boolean can only be true or false, but the none type can actually only contain the value none. So why is this even useful? Well, the idea of none is to communicate that there's nothing here, and not just the value 0, because sometimes 0 means something. Again, let's go back to our example of a variable called age selection. Let's say we have a form on our website where you can input an age. Well, inputting the age 0 would actually be a valid selection. So we can't use 0 to represent the state where the user has not yet selected an age. Again, because you could select 0. So one common use case with the none type is to sort of use it as a default value for a variable. And it indicates that, nothing is stored here yet, but there likely will be or can be in the future. Now, one common mistake I see with new Python developers is when they print a value, or I should say when they print a variable that stores the none value, it will actually print the string none to the console. And that's confusing because if you write a program that instead of printing a variable that stores the none type actually prints a string that just says none, the exact same thing is printed to the console, but they're not the same. Now, the easiest way to test is to actually wrap the variable in a type function. So you're actually printing the type of the thing. And in that case, you'd get a message saying, this is a none type or this is a string type. So if you ever get stuck or lost and you're not sure what you're looking at, be sure to use that in your print debugging.
All right. Well, again, I'm not sponsored or anything, but we ought to. Before, it's been an amazing thing for me to use as a new potential game creator. It feels really good to use. As we mentioned in the last exercise, the none keyword is used to define an empty variable. So when would you use it? One use case is to represent that a value has not been determined yet. For example, an uncaptured input. Maybe your program is waiting for you to enter the name. You might start with the variable. Username equals none. Then later in the code, once the user has entered the name, you then assign it to the username variable. Username equals input. What's your name? Remember that it's crucial to recognize that none is not the same as as the string none. They look the same when printed to the console, but there are different data types, beta types. If you use none instead of none, but if you use string none instead of normal none, you will end up with code that looks correct when it's printed, but fails the test. Okay, when might you use a none value? Default. Yep. Okay. Pretty easy. Dynamic typing. Python is a dynamically typed, which is dynamically typed. I mean, a variable can store any type, and that type can change. For example, if I make a number variable, I can later change that variable to a string. Speed equals 5, equals 5. Like, me don't. In almost all circumstances, it is a bad idea to change the type of a variable. The proper thing to do is just create a new one. For example, speed equals 5, and then speed description equals 5. What is non-dynamic typing? Languages that aren't dynamically typed are statically typed, such as Go, which you'll learn in a later course. Okay, in a statically, I don't know, typed language, if you try to assign a value to a variable of the wrong type, an error would crash the program. If Python were statically typed, statically, alright, but if Python was statically typed, the first example from before would crash on the second line, speed equals string 5, whatever, 5. Computer would give an error along the lines of you can't assign a string value 5 to a number variable speed. Alright? And changing the type of variable generally a good idea. What? No. I might come back and watch this. I don't know. Because I already watched the previous one. This might just be recapping whatever I just linked here. I'll come back to it later. Probably after the stream. So the other one is. What kind of typing does Python employ? Static. Yeah. What? Okay. Oh, I'm blind. I completely forgot about this up here. Thought it was just I'm dumb. Okay, yeah. That's my bad. I am really slow. Alright. Math with strings. When working with strings, the plus operator performs a concatenation. That okay, whatever, Wikipedia. Concatenation. Concatenation. I don't know. Con. When working with strings, the plus operator performs a con, which is a fancy word that means joining two strings. Generally speaking, it's better to use string interpolation with f strings over plus con. First, so like first name equals string Elaine, for last name string what? Wagner? Yeah, Wagner. Full name equals first name plus last name, print full name, prints Lane Wagner. Full name now holds the value Lane Wagner. Okay? Notice that the extra space at the end of Lane, the first variable. That extra space is there to separate the words in the final result, Lane Wagner. Assignment, we have a second player in our game. Okay. We need to tell each of our players how much health they have left. Edit line 9 to print players 1 health. You have. Okay. This should just be print player. Oh wait, no. No, so it's print sentence start. Wait, no. And start. Actually, no. Legend start plus. Oh, shoot. One underscore health. There. So I'm gonna do. We take that. I'm hitting control. Player 1 underscore health. See my. Yeah, okay. Make sure my mic was still working. Okay, so, screw up, I'm just gonna type player 1 underscore health plus sentence end. We do player underscore 1. Does that work? Good. Okay, so now we take that. Take, and then we do player 2 health and player 2. We do player underscore 2. That worked. That's nice. That's good. Okay, so mine was level 6 on this. That's neat. Alright, multivariable declaration. We can save space when creating many new variables by declaring them on the same line. Store name, store damage, store length, caliber, 10, 200. The same as doing that. Yeah, that's honestly a lot. Okay, any number of variables can be declared on the same line, and variables declared on the same line should be related to one another in some way, so the code remains easy to understand. Call it, we all call this under easy to understand, clean code. No limit. Yep, okay. Easy. What is clean code? Clean that is easy for developers to read and understand. Alright, don't just above this line, so for everything down here. I gotta do everything down here. Okay. Alright. Boot. You may have already figured out this by now, but below the less than explanation, or in the boot tab on mobile, there's a double bear wizard named Boots. Hello, Boots. His job is to help you if you get stuck. Here's how. Boots is a. Okay, so let's just simply talk about what Boots is. Okay. Before you go to the lesson, called a big salmon. I don't think I have a big salmon. If you don't have one, 50% of the XP you earn from completing the lesson. When you pay 1 per lesson to start the conversation, time will boost after you complete a lesson free. Use okay. Alright. Fancy quest dialogue. Notice that nothing prints console. Ask me why nothing is printing. Clipboard icon on text input to include your code. So you can see. It's only what's below the comment. News. Intentional has the starting code. Use boots to figure out what's going on through the code and submit it where it's been. Okay, so I have to do that. Period. Okay. Um. Nope. No, I don't need Discord. Okay, so I can just tell him, ask him, why is nothing printing? Okay, yeah. Ah, my curious apprentice. I see you've pasted your code, but it appears to be empty below the comment line. Let me ask you this. What do you think need to happen for text to appear on the console when you run a Python program? Think about it. You have all these wonderful quest dialog variables defined at the top, quest dot, quest middle, etc. But what Python command would you use to display them to the user? Take a look at the expected output, at what the expected output should be, and then consider what Python function have you learned that can display text to the console. Okay. Hello, user traveler, okay. Mm, I'm assuming it's just print quest start, print, no, quest middle, and if I just do quest objective, what happens with that? Okay, hold on. Okay, we're going to do quest final, no, quest underscore final, underscore final equals quest end plus quest objective. So, and we're gonna do quest final. Okay. Space. Space. Plus quest objective. So now that should fix that. Yes. First, yeah. I write out less XP because I was forced to use him. I don't above this line, don't below this line. So for this one, have to do it in the average score box. Okay. Spellbook. As you progress through boot.dev, you might find yourself wanting to take notes, view content you've already learned, see more examples of the concept, seeing about some syntax you already learned, and that involves the spellbook right here. A lot of stuff. Okay. It's a lot. I feel like creative by completing lessons so far I have 12 pages. Seems. Oh, not me click that. Okay. Okay. Assignment. Competitive Fantasy Quest players. Bowen's Ballers have won all their games in the elimination round of the tournament. They're now in the finals. calculate the average score of their 4 games and score in the average score variable. The average or mean is calculated by adding up all the numbers and dividing by how many numbers there are, which means. Okay, well, look at the bottom right of the lesson text. You see the toggle next to why do I need to use the spell book? I mean, I pretty much know what to do. Total score equals. We do game 1 score plus game 2 score plus game 3 score plus game 4 score divided by 4. On this one, or do I just simply have hold on, no, hold on. Actually, Python math. Python math. Okay. Actually, oh wait, oh, I'm blind. Average score is what this is supposed to be. So this is meant to go here. I run it 100. That's okay. Yeah, I was just overcomplicating it. I just had a lot. Now that I'm realizing, I overcomplicate a lot of stuff. Anyways, on to the next lesson. Character report. One of our interns built a program that prints information about Fantasy Quest player characters. It's almost done, but when you were reviewing his code, you found some bugs. Fix the bugs to get the character report working. Run the code to see it fail. File Windrunner. Okay, I'm gonna fix the bug on with the F string on line 9. Line 9. It's gonna be F. Print name is a level character. Okay, with the F string on line. Okay, so hold on. So name Lopin, level 25, Windrunner, character class, Windrunner. I'm assuming. Try Okay, so character for Lopin A, level 15 Windrunner. Okay, they have a 12.4 armor, 50 magic, it's currently active. What happens if I remove Windrunner? I just want to see what happens if I remove it. So then I go back to run the code, update the syntax in the data table you'd expect. First off, Windrunner, you need to be fixed. I remember that. Windrunner. So name string level is a integer. Running it. Character class string armor float. Float. No, float was float very. Okay. The float is decimal. Armor decimal. Okay. Plus 0.0. The boolean, which is that. Now that should be all correct. Oh, yay. Nice. Let's go. Now, chapter 3 of Python. I'm getting, it's been really fun. Well, alright. Functions allow us to reuse and organize code. For example, say we have some code that calculates the area of a circle. Radius equals 5, area equals 3.4 times radius. That works. The problem is when we want to calculate the area of other circles, each with its own radius. We could copy the code and change the variables names like this. We want to reuse our code. Why would we want to redo our work? What if we wanted to calculate the area of thousands of circles? That's where functions help. Instead, we can define a new function of area of circle using the def keyword. Def area of circle r pi equals 3.14 result pi where r return not square times r return result. Let's break this area of circle function down. It takes one input, aka parameter or argument called r. The body of the function is indented. This is the code that will run each time we use, aka call the function. So yeah, use a function. It returns a single variable, the output of the function. In this case, it's the value stored in the result variable. To call this function, fancy programmers speak for use this function. We can pass in any number as the argument. In this case 5 for the parameter r, and we capture the output into a new variable. Area equals area of circle, r5, print equals print area, which is 7.5. 5 goes in as the result. The input r, body of the function run, which stores 78.5 in the result variable. The function returns the value 78.5, which means the area of circle 5 expression evaluates to 78.5. That's kind of all it is right now. 78.5 is stored in the area variable and then printed. Because we've already defined the function, now we can use it as many times as we want with different inputs. And area circle 6. Yeah, okay. Then we need to calculate the size of weapon attack area with a 1.0 meter sort. For example, when a player can attack an area of 3.14 square meters around them, we can use the area of the circle function to do that calculation. Click the button on line 13 by calling the area of a circle function with the sphere length, right? Using the area of circle function with the sphere length as input and store the result in the sphere area variable. Okay, so 13, calling the sphere area. Okay, hold on, let's see what happened here. Okay, so that works fine. But I need to fix on line 13 by calling the area of circle function with the sphere length. So, store length meters. Store 0 meters. Area circle. Okay. Oh, yeah. So, no, not only that. Area circle sphere. Does that one work? That makes it work. Yeah. All right. Function overview. Functions are tricky. It takes a minute to get used to them, but after that, they'll be second nature to you. You might find yourself slowing down a bit in this chapter, and if you do, that's totally normal. What kind of function? Yeah.
Functions are the building blocks of real-world applications. They make it so we can reuse the code that we write, and they help us organize our code into smaller pieces so that it's all easier to keep track of. Let's take a look at this example, a function that calculates the area of a circle. It takes the radius of a circle as input, in meters, we'll be using the metric system for this example, and when it's done, it will return the area of the circle, in meters squared. Here's the code that defines the area of circle function. If all we do is define the function, it won't actually do anything. We have to call the function in order for it to execute. Let's call it with a radius of 5 as the input. Now, when the function is called, execution jumps back to the function definition. A new variable that's only available inside the function, called pi, is created with a value of 3.14. Next, we save the result of pi times r to a new variable called result. The area of a circle is pi r squared after all. Finally, we return the result from the function as its output. Execution jumps back to the function call at this point, and we capture the return value in a new variable called area. And if we want to, we can just print it. The best part is that we can then call it again with a different input, getting the associated output, and we can do it again and again and again as many times as we want.
All right. That's neat. Okay, that sounded easier. What the? What comes first? Okay. The chronological explanation of what happens in the above code is executed. Area of circle R, radius. Okay, this is tedious. A new variable called radius is created. No. A circle function defined for later use, not called. Defined. Yeah, okay. Alright. This is the same way, I'm guessing. So, I will try which step happens last when the code is executed. So, a function is called already out. That's the first one. Of pi calculated. The result. Okay, so that calculated and stored in the result variable. Function is defined. I don't know why is it called? It's defined. Called. So it's not yet. No. Oh, it's the wrong one anyways. Okay, so either calculated or returned. Yeah, okay. Same video. Right. Why is the variable called radius outside the function or inside the function? Yes. Yes. Because only the value of the variable is passed to the function is then assign to a new variable called R. All variables are called R is equal to yep, okay. And multiple parameters. Functions can have multiple parameters. Parameter being a fancy word for input. For example, this subtract function accepts two parameters, A and B. Actually, but this has been a nice little time. I've really enjoyed doing this. Running code on stream. But I feel like that's gonna end it for today. Next time I'll stream, either gonna play a game or continue this. Yeah. Bye. Good night seeing y'all. Good night. Bye.